this question says, write the augmented matrix of the given system of equations. We have the system of equations with 3 equations and 3 variables, x, y, and z. Our augmented matrix will have 3 rows matching the 3 equations, and it will have a column to match the x's, a column to match the y's, a column to match the z's, and a column for the constants. So before I write the matrix, what I want to do is rewrite the system so that the variables are in line with each other. So to do that, the first equation I can leave alone because it has all the variables and the constant. The second equation is missing a z term. I'm going to line up the x term and the y term, leave a blank for the z term, and then write the rest. The last equation has all the variables, and I'll line up those variables and the constant. And now I'm ready to write the matrix. The matrix will have 3 rows and 4 columns. In the matrix, we write the coefficient on the variables as the entries of the matrix. So the coefficient on x is 1, the coefficient on y is 1, the coefficient on z is -1, and then we have our constant of 3. For the next equation, we have coefficients of 3 and -6, and since we don't have a z term, we're going to consider that to be a 0z. So we have 0 and 3. For the last equation, the coefficients are 2, 4, and -1, with a constant of 1. And to indicate the difference between the coefficients on the variables and the constants, we draw a line. So this is our augmented matrix. Solve the following system of equations using matrices, row operations. If the system has no solution, say that it's inconsistent. The first thing I want to do is write the augmented matrix for this system of equations. This system of equations has 2 equations, so we'll have 2 rows, and we have 2 variables and a constant, so we're going to have 3 columns. So our augmented matrix is 1, 5, 8, 4, 20, 32. Now to solve this system, to solve this matrix, what I want to do is to get the matrix in a format where I have a 1 and a 0 like this. Basically, I need to eliminate this term, and if I eliminate that term, I'll be able to solve the system. So if I want to eliminate that 4, I need to multiply -4 times row 1. -4 times 1 is -4, and when I add that to row 2, that will eliminate that position, and this will become my new row 2. So I'll do the math right here. -4 times row 1 would be -4, -20, and -32. I'm going to add that to row 2, which is 4, 20, and 32. And if I add those, I get 0, 0, 0. So my new system becomes, the first row stayed the same, 1, 5, 8, and the second row became 0, 0, 0. Now when we have a situation like this, where we intended to eliminate one term, but we ended up eliminating both, we have one of our special cases. You either have a system that has infinite solutions, or you have a system that's inconsistent or has no solution. So what we're going to do is look at this last equation, and this last equation would be the statement 0 equals 0, which is a true statement. So because of that, this system has infinite solutions. So I'll use the first equation, x plus 5y, to see what those solutions look like. I can subtract 5y on both sides to get x equals negative 5y plus 8. So the solution to this system will be all ordered pairs, xy, that are on the line x equals negative 5y plus 8. Or you could write your solutions as ordered pairs, and the x-coordinate of the ordered pairs is always negative 5y plus 8, and the y-coordinate is y. Solve the following system of equations using matrices row operations. If the system has no solution, say that it's inconsistent. So here's my system. X minus y equals 3. 7x minus 3z equals 35. 7y plus z equals 14. I want to write the augmented matrix for this system. I have 3 equations, so I'll have 3 rows. I have 3 variables, x, y, and z, and also the constant, so that means I'll have 4 columns. So in the first equation, the x term has a coefficient of 1, and in the first equation, the y term has a coefficient of negative 1. There is no z term, so I'll put 0 to represent no z term, and then I have my constant being 3. In the second equation, I have a coefficient of 7 on the x term. There's no y term, so I'll put 0. A coefficient of negative 3 on z, and 35 for the constant. In the third equation, I have no x term, so I have 0. 7 is the coefficient of the y term. 6 is the coefficient of the z term, and 14 is the constant. Now to solve this system, what I want to do is get the equation to a state, or get the matrix to a state where I have 1s along the diagonal and 0s in these positions here. This is going to allow me to solve the last equation and then back substitute into the second equation. That'll allow me to solve for another variable. Then I'll back substitute into the first equation. I'll be able to solve the last variable. So what I'm noticing is that I already have the 0 that I want in this position. So that's done. The next one I want to focus on is putting a 0 in this position. So to do that, I'm going to multiply a negative 7 times row 1 and add that to row 2. This will become my new row 2. So negative 7 times row 1 would be negative 7, positive 7, 0, and negative 21. And I'm going to add that to row 2, which gives me 7, 0, negative 3, and 35, I'm going to add these rows together to get 0, 7, negative 3, and 35 minus 21 would be 14. So this is my new row 2. So my new system, the first row and the third row stay the same. And my second row becomes 0, 7, negative 3, and 14. So the next thing I want to focus on is getting a 0 in this position here. And to do that, I need to do negative 1 times row 2 plus row 3. Negative 1 times row 2 is 0, negative 7, positive 3, and negative 14. I'm going to add that to row 3, which is 0, 7, 6, and 14. And to add those together, I would have 0, 0, 9, and 0. So this is going to be my new row 3. I'll write my new system, which is 1, negative 1, 0, 3, 0, 7, negative 3, 14. So row 1 and 2 didn't change. And then row 3 becomes 0, 0, 9, 0. And ideally we would have 1s along the diagonal, but you actually don't need them to solve the system. All you need is these zeros here. So I'm going to go ahead and solve the system. I'm going to turn this matrix back into a system of equations, and that would give me x minus y plus, I'll leave off that plus because that's plus 0, equals 3. Then the second equation is 7y plus, that's minus 3z equals 14. And finally 9z equals 0. So with this system, we can solve this equation by first solving the last one. So the last equation is 9z equals 0. Divide by 9 and z equals 0. That allows you to substitute into the second equation 7y minus 3 times 0 equals 14. That's 7y equals 14. Divide by 7 and y equals 2. And now I can substitute a y of 2 to find out what x is. X minus 2 equals 3. I'll add 2 to both sides, and x equals 5. So the solution to this system is the ordered triple 5, 2, 0. Find the value of the determinant. So these vertical bars are the symbols that we use for determinant, and inside we have a matrix. There's a formula for calculating the determinant. So we have matrix A, which is A, B, C, D, and we want to find the determinant of matrix A, B, C, D. And the formula is A times D minus B times C. So for this one, we can find the determinant by doing A times D, negative 3 times 5, minus B times C. So 1 times negative 1. So that's negative 15 plus 1, which is negative 14. We can also do this calculation in the calculator. So we're going to enter in the calculator this matrix. So we want to go to the matrix menu by hitting second and this x to the negative 1. I'm going to move over to edit the matrix. I'll edit matrix A, and I want this matrix to be a 2 by 2 matrix, 2 rows and 2 columns. Our matrix is negative 3, 1, negative 1, and 5. Then I'm going to go to the home screen. I'm going to go back to the matrix menu by hitting second and x to the negative 1. I'm going to hit the right arrow to get the operations on matrices. The first one is DET, which stands for determinant. And I want to find the determinant of matrix A, the one I just typed in. So I need to go back to the matrix menu again, and I'm selecting number 1 to select matrix A. And then it will do the calculation of the matrix, or the determinant, for me. Determine whether CB is defined. If it's defined, express the result as a single matrix. If it is not, say not defined. So CB is representing matrix multiplication, and that's multiplying matrix C by matrix B. In order to determine if it's defined, we have to make sure that the size of these two matrices match up so that we're able to multiply them. So we want to do C multiplied by B, and I can see that matrix C has 3 rows and 2 columns. Matrix B has 2 rows and 3 columns. In order for this matrix multiplication to be defined, the number of columns of matrix C has to match the number of rows of matrix B, and you can see that they do match. So the matrix multiplication of C times B will be defined. Now we are going to create a new matrix with this multiplication, and the new matrix will use these other values to create the size of that matrix. So our new matrix will be a 3 by 3 matrix, 3 rows and 3 columns. So let's call this new matrix matrix D. So matrix D will have 3 rows and 3 columns. So I'm going to write the entries of this. We don't know what the entries are right now, so I'm going to use some symbols to represent them. So the first entry is D11, which stands for row 1, column 1. Then D12, that's row 1, column 2. D13 is row 1, column 3. Then we have D21, row 2, column 1. D22, row 2, column 2. D23, and I think you guys are getting the picture, so we have D31, row 3, column 1, D32, and D33. Each one of these entries represents a calculation that we have to do in this matrix multiplication. So let's start with the calculation of D11, entry D11. So the entry in the first row in the first column. So what we're going to do is we're going to use the row from matrix C and the column from matrix B. So this is entry 1, 1, row 1, column 1. So I'm using row 1 of matrix C and column 1 of matrix B. And I'll use 6 times 5 plus 1 times negative 3. So I used the 6 and the 1 from row 1 of matrix C, and I used the 5 and the negative 3 from column 1 of matrix B. So if we do that multiplication, we'll have 30 minus 3 is 27. So our entry in the first row and first column of this matrix is 27. Let's do the next entry, D12. To do this calculation, we want to use row 1 of matrix C and column 2 of matrix B. So this is going to give me 6 times 1 plus 1 times 5. That's 6 plus 5, which is 11. And let's do D13. So we're going to use row 1 of matrix C and column 3 of matrix B. So in that calculation, we would have 6 times 0 plus 1 times negative 6. That's 0 minus 6, which is negative 6. And let's do D21. So with D21, we're going to use row 2 now. So instead of row 1, we use row 2. And column 1 of matrix B. So that would give me 6 times 5 plus 3 times negative 3. That's 30 minus 9, which is 21. Then we'll do D22. So I'm still using row 2, but now I've switched to column 2. So let's switch this to column 2. We're going to do 6 times 1 plus 3 times 5. 6 plus 15, which is 21. And let's do D23. So we're keeping the row the same, but now we're going to do column 3. So that's 6 times 0 plus 3 times negative 6. 0 minus 18 is negative 18. Okay, let's try D31. I'm going to do row 3 of the first matrix, which is C, and column 1 of the second matrix, which is B. So that calculation would be -5 times 5 plus 2 times -3. It's -25 minus 6, which is -31. And D32, we're going to switch that first column to be the second column. And we have -5 times 1 plus 2 times 5. So -5 plus 10 is -15. And the last one, D33, let's change that second column to the third column. And our calculation would be -5 times 0 plus 2 times -6, which is 0 minus 12, and that's -12. So this is the new matrix of C times B. We can also do this calculation in the calculator. So I want to go to the matrix menu, which I'm already in, go over to Edit, and I want to edit matrix C. Matrix C is a 3-row and 2-column matrix, and the entries are 6, 1, 6, 3, -5, and 2. Then I'm going to go back to the matrix menu, go over to Edit, and I want to edit matrix B. Matrix B has 2 rows and 3 columns. And the entries are 5, 1, 0, -3, 5, and -6. And now that I have these matrices edited, I'm going to go to the home screen, and I want to multiply these two matrices on the home screen. So I need to select matrix C. I'll go to the matrix menu, and I'm going to select number 3. I want to multiply that by matrix B. I'm going to go back to the matrix menu and select number 2, that's matrix B, and hit enter, and the multiplication is complete for us. So let's compare our work by hand and this work in the calculator. So we've got the entries of 27, 11, -6, 21, 21, -18, -31, 5, and -12. So it looks like I might have a mistake here. And I can see my mistake right now. -5 plus 10 is not -15. So let's correct that. -5 plus 10 is 5. So this entry should be a 5. Okay, looks great. Determine whether the product is defined. If it's defined, find the product. If it's not, say not to find. So we have 2 matrices here that we want to multiply, and to determine if this product is defined, we have to look at the size of each one of these matrices. The first matrix has 3 rows and 3 columns. The second matrix has 3 rows and 2 columns. So the product will be defined when the number of columns of the first matrix match the number of rows of the second matrix. So since these match, our product is defined, and our new matrix will be of size 3 by 2. So we're going to have a 3 by 2 matrix when we do the product. So let's call this matrix A. For matrix A, it has 3 rows and 2 columns. So it will have entries A11, A12, A21, A22, A31, and A32. These subscripts are referring to the row and column that entry is in. So A11 is the entry in row 1, column 1. A12 is the entry in row 1, column 2. Each one of these entries is a calculation that we need to work out. So let's work out the entry of A11. So to do this calculation, we're going to use row 1 of the first matrix and column 1 of the second matrix. And we do multiplication entry by entry. So that would be 1 times 1 plus 0 times 6 plus 1 times 2. And that's 1 plus 0 plus 2 is 3. A12 will use the second column instead of the first column. So this would be 1 times 2 plus 0 times 1 plus 1 times negative 1. That's 2 plus 0 minus 1, which is 1. A21 will use row 2 instead of row 1. And it will use column 1. And we'll do the multiplication entry by entry. So that's 3 times 1 plus 2 times 6 plus 1 times 2. If you've noticed, these second numbers are all coming from the second matrix, and these first numbers are all coming from the first matrix, either from row 1 or row 2. So to finish this calculation, that would be 3 plus 12 plus 2 is 17. Then let's do entry A22. So we're going to use row 2 from the first matrix and column 2 from the second matrix. So the calculation would be 3 times 2 plus 2 times 1 plus 1 times negative 1. 6 plus 2 minus 1 is 7. Entry A31, row 3, column 1, will use row 3 of the first matrix and column 1 of the second matrix. So our calculation would be 3 times 1 plus 6 times 6 plus 1 times 2. That's 3 plus 36 plus 2 is 41. Then A32 will use row 3 and column 2. It's 3 times 2 plus 6 times 1 plus 1 times -1. That's 6 plus 6 minus 1 is 11. So our matrix is 3, 1, 17, 7, 41, 11. We can also do this calculation in the calculator. So I'm going to go to the matrix menu, and I want to go over to edit, and let's edit matrix B, and I'm going to make the first matrix, matrix B, which is 3 rows and 3 columns with entries 1, 0, 1, 3, 2, 1, 3, 6, 1. I'm just double checking I have it typed in right. And now I want to go back to the matrix menu again. I'm going to edit, go over to edit, matrix C. And matrix C has 3 rows and 2 columns with entries 1, 2, 6, 1, 2, and -1. And I've got that one entered correctly. I'm going to go to the home screen and back to the matrix menu because now I want to multiply matrix B by matrix C. And we get the matrix. Where'd my calculator go? We get the matrix 3, 1, 17, 7, 41, and 11.